Okay, we'll hold on one more minute. And maybe we can, I think, does everyone see the participant list? I don't know if we have to go through formal introductions. We have, it looks like, participants from all the relevant MPOs, the district and central office on the phone. So I can jump right in if we want to. We'll hold it one more minute. Well, just in case, I'll do some quick introductions. Obviously, I'm Dan Sakaris from Michael Baker. I'll be leading the presentation here, and I'm joined by Avinash Sinha, one of our main modelers here at Michael Baker, who's going to provide some of the training at the end here as kind of showing the model. We do, Anna and Tushar, I'll introduce you. We have some additional members of our consultant team, Anna Alinik, Tushar Patel from AECOM. From PennDOT Program Center, Jackie, I guess you can lead off here. I don't know if there's, I'm looking through the list, if there's anyone else from Program Center.
This is Beth Raves. I'm joining in.
Okay, hi Beth, yep.
Thanks.
From the district office, anyone from PennDOT District?
This is Matthew Klauser. I'm the ITS and Congestion Management Manager at District 8.
Thanks, Matthew. And I believe Nathan's on.
I think he's on, Dan.
Yeah, Nathan Rice. I'm the safety section supervisor.
Okay. I see York County's on.
Yep, I'm here, Dan.
Okay, well. Lancaster.
Hi, Dan. It's Bob Bay. I think there are a couple others from the.
Hey, Bob.
They're bashful. I think Lori and Christiana are on as well.
Yeah, okay, you got the whole crew then. I'm going around the circle here. Lebanon. John, we just emailed, so I know you're on.
Yeah, John and Song are on.
Okay, welcome.
Welcome.
From Hats.
Yeah, Dan, it's Steve Deck with me. Diane, Andrew, and Ben Werner are here in the conference room. I think Kyle is on remotely as well.
Great. Franklin County. I think Steve emailed me he couldn't make it today. Anyone from Franklin on?
I think Hanan is on vacation, Dan, so I
Okay.
don't think so.
That would be. And then Adams County.
Yeah, Andrew, Laura, and Sarah are here.
Okay, great. Anyone else that we didn't touch hit there? Who wants to introduce themselves? Okay, otherwise we'll get started. Jackie, unless you want to provide an intro, I'm just going to keep going here. I'm going to get started here.
Nope, I think everybody knows who I am. So Jackie Koonsfilian from PennDOT Program Center, and welcome everybody, and all good to go there, Dan.
Okay. So what do we have on tap here for today is an update on the South Central model. So I'm gonna go through probably, hopefully in just 10 to 15 minutes, talk about where we are at with the model, and some of the next steps, the remaining steps here to finalize the project. In addition, we wanted to have a little discussion on maybe the next steps here as far as model maintenance and application. Certainly we're creating a travel demand model. Now the question is, who's going to maintain it? Where do we house it? And how do we all contribute to it moving forward and for what type of projects. So we want to have a little discussion on that. I have a separate Excel spreadsheet that I had sent out by email that I wanted to go through to get some conversation started. So I'm guessing that's going to take at least a half hour to 45 minutes. The remaining time was going to be kind of reserved for training on some of the model basics. And that's where we wanted to go through the entire travel demand model, kind of highlight a little bit about travel demand modeling, show you some of the information from this South Central model and what it looks like. And then the last 30 minutes or more, actually have Avinash open up the model in the software and do a demonstration within the Cube Voyager. So kind of give you a better sense of what we're talking about here with the model, what it looks like. Again, with all this training, I don't think anyone's going to become an expert of watching this training. Some of it will get a little overwhelming, or you'll realize I can't remember all that. That's understandable. It's really just intended to give you kind of an idea of what it looks like. And certainly there'll be a user's guide that comes along with it. And certainly I'm guessing that any application or use of the model is probably going to have our assistance here in the near future. So I don't know if everyone's going to intend on staying on the whole 2 hours here. So anyone's welcome to drop off maybe after the project update if they feel that they don't really want to see all the details of the travel demand model, which will happen in the second half of the presentation. So I'll get started here on really a status of the South Central model expansion. And I guess leading into this, I just want to give a little background, a context of where we've come regarding the model. And I start my story back in 1994. I was just a young man coming out of Penn State University, and my first job was to work under PennDOT's Program Center contract, the same one I still work under all these years later. And my first, one of my very first tasks was the help in the development of the Berks County travel demand model and household survey. And you ask, well, why Berks County is really not part of this region? But really, it set the stage for PennDOT's Program Center to play a more active role in travel demand model development within the state. And when they developed the Berks model, the intent was that could become a framework to be used by other MPOs. And in fact, it did become a framework. It became a framework. That Berks model became a framework for the subsequent Lancaster, Harrisburg, Reading, obviously Reading because that is Berks, Lehigh Valley models. And even recently, some of those concepts have rolled into SPC's model. So certainly back in '94, that really set the great framework for all the modeling. In the late 1990s, York, I think Will's on the phone, they had worked to develop a travel model in their own software. And I know early on we had some issues with US 30, a major project going on, and developed a corridor model for Lancaster. And that eventually got expanded into a county model, especially as the air quality requirements came into play in those mid-1990s to be used for transportation and conformity. And since that time, a lot of the models have been updated. In the mid-2000s, Lancaster County, back in the days of Chris Newman, went through an effort to update and do a whole household survey to update their models. York model was updated in various forms. And then later in the 2000s, there was the development of the Harrisburg regional travel model. And as we went through all those developments of those models, we realized that each model does a good job of what's happening in their own region, but it really has trouble understanding anything that happens outside of those model regions. So we realized there were so many connections between Lancaster, Harrisburg, York, all these District 8 regions, that it would be better suited to have them all in one model. And that's been talked about for several decades. So really, that didn't happen until a few years back, where we started the initial South Central model development, and we combined the Lancaster, Harrisburg, and York models into one model. And then the thought process there was to add on to the entire district region with Adams Franklin, and Lebanon counties. So that's kind of where we are today. Over many years, this model has taken fold to develop. So the scope of our latest work, what I talked about a few 2019, 2020, really developed of the original South Central model. The latest work order that we had was the expansion of the model, the Franklin, Adams, and Lebanon's. Along with that, though, when you start to expand the model, other things change in the main model that we had for the previous 3 counties. So we have new data that's coming in. The external, the longer distance travel things have been updated. The interface of the whole model has been updated. So there's project items here that don't just apply to Franklin, Adams, and Lebanon. They apply to the entire model region. But certainly for this task order, as we're talking about adding counties, we needed to develop a new highway and transit network for these 3 new counties. We had to develop socioeconomic inputs, which go into the travel demand model. We had to update all the scripts and the interfaces I talked about. And then we had to do all new validation assessments of the model to make sure it's working and operating properly. So those were our tasks that were laid out for this particular effort. So I guess where I'll just backing up, I'm going to give a kind of where we are at now. We have an operational model. The model is working and it's pretty much in near final form. Everything's running and every process is set up. And that included expanding the highway network that I talked about here. This shows all the roadways that were included. For the 3 new counties, we really relied on PennDOT's roadway management system and its GIS layers as a starting point to bring into our new system. This software is a completely different format. It doesn't really operate in our traditional ArcGIS world. It has its own binary format. So it required translating and updating those RMS GIS files into a format that could be accepted through this model software package. Obviously, we had to link the models together, these networks together with the existing counties. So we had to create those interface links and put them all together. We still are tweaking with the network. There's a lot of data that goes into these roadway networks. We have information on the physical lanes, intersections, all kinds of information that goes into the travel model. I know some of the counties, I'll talk a little bit about how MPOs can help, like Adams County was able to just provide us some information on intersection turn lanes and center turn lanes in their region. So we're still updating some of that information into the network. And I imagine as we move forward, will be an evolving product. Data will constantly being updated, reviewed, and added to the travel model. Along with that, we have a transit network that needs to be reflected because our model is multimodal in nature and does reflect the fixed route transit routes within the region. Our travel model is for a weekday, so most of our transit routes will focus on those routes that operate specifically on a weekday. So obviously data, was provided from each of our transit agencies, and that included information on how often they run, the frequency, the times, and even the fare information, because all of that goes into the model and deciding how many transit trips are taken. For the Adams and Lebanon counties, we were able to grab the transit information and include them. What you see here is missing some of the fixed route transit routes in Franklin County. CAT does have several Shippensburg routes. They have been actually completed since this slide was created. So I have a green there. They're still being kind of validated and making sure everything's working properly. But those several routes were missing in our draft model. So we have recently updated that. What drives the travel model, the number of trips, are information on our land use and socioeconomics that are prepared at a traffic analysis zone level. So this is the TAZ level. We have a TAZ system that's rather defined for the existing 3 counties. For the new counties, we have set up a traffic analysis zone system based on the census block group geography. And we've used that to really drive the socioeconomic inputs to the travel model. As we set this model up, we realized too that we may have set up zones in Franklin, Adams, and Lebanon at the census block group level, but that down the road there may be further refinement of those zones to improve the model performance or to reflect, specific development in areas where it may be needed to break a zone up into different sub areas. So we've set the model up to more easily allow for these changes down the road. They can easily be added into the system with input from the MPOs moving forward. And each of these concepts I'm going to talk a little bit more about in our training at the end. So, what is a TAZ system? What is the network? What does it look like? What is the data? We'll capture that in the second hour. For each of these TAZs, we need a bunch of data on our socioeconomics as far as employment by different groups. We have commercial, service, and industrial employment. We needed the households. We have information on income and school and university enrollment. Again, we utilized information from census, but we also utilized information from some of the employment data that PennDOT has acquired from the Department of Labor and Industry. And we were able to geocode that employment data down to these TAZ level to get estimates of the different employment information. So that's why in some cases we didn't come to the MPOs for this information. We made use of what's available from census and what's available from PennDOT. In some cases, we needed a little help on some of the school and university enrollment, so we did reach out to each of the MPOs to help with the collection of that data. Now, for the existing 3 counties, Harrisburg, Lancaster, and York, we continue to utilize your adopted MPO forecast that you already had and the data that you already had from previous iterations of the model. Obviously, I've told you before, the way this travel model is set up in this software platform is almost like a programming language. And there's lots of scripts and programs with their own, in essence, their own language and keywords. So we needed to update those scripts to reflect the addition of these new model regions and new model areas and the processing of those areas. Oops. And what we have here is kind of the overall structure of the model. And again, I'm going to talk in my training session on each of these steps, what you see on the right-hand side. This model follows what's called a traditional 4-step model. There's really 5 steps, but the whole model chain is the base of it is the 4, which is the trip generation, where you're generating trips. The trip distribution, where you're distributing those trips to different areas within your model region, and that's to those TAZ, the traffic analysis zone areas. You're deciding what mode of travel they choose, whether it's transit or other types of modes or vehicles, the time of day that those trips are taken, and then ultimately you assign those trips to specific roadways into the network, and that's where traffic congestion can come into play. The model is set up in a software called Cube Voyager. It's maintained by a company called City Labs. Actually, that's been bought out by a firm called Bentley right now. And that's one of the probably 3 primary software platforms that are used within the United States for travel demand modeling. It is also the software platform that's used by the PennDOT's statewide travel demand model. Along with Cube Voyagers and with the additions of these counties, we make use of a supplemental piece of software called Cube Cluster. which is really an optimization type software for running these analyses to make it more efficient and to run faster. So we make use of the Cube Voyager and Cube Cluster software programs. Currently, if you're running any 1 year of that model, it takes about an hour to run. There are a fair amount of zones, and actually an hour of runtime is pretty good compared to historically what models used to take to run. When we set up the entire South Central model with the new model regions, we want to make sure that the model's doing a decent job and producing volumes that are somewhat consistent with actual traffic volumes. So we perform a process called validation. And for the validation, we utilize lots of counts, and primarily we grab those counts from the roadway management system. We did some traffic, what we call traffic count cleaning, but it's really choosing traffic counts at the appropriate locations, at more mid-block locations. Or when I say mid-block, between two of our intersection locations on the model network, assuming it's somewhere in the middle. So we have about over 6,000 counts that we've used for the model validation. We also used Census LEHD data, look at general trips between counties. Obviously the HPMS VMT, making sure that we're consistent on VMT, and then transit trips that we look at. We're actually still finishing up some of the transit trip validation. It won't affect the overall traffic volumes too much because our transit percentages are pretty low, but we are tweaking some of the formulas for transit ridership. Along with that, the model doesn't really, this is one of the purposes of why we combine the model, but models really don't know what goes on from what we call these external stations along the edge of the model. Anything beyond that, it doesn't understand what's happening, and rightfully so. There's no information on that. So for example, on through trips, that information has to be provided to the model, or how many trips at each of these external locations are going through versus staying within the model region. So to come up with that information, there's a couple of ways you can do it. You can use information from a statewide model like we have for PennDOT, which is what we've used in the past. For this particular exercise and this update of the South Central model, we actually made use of streetlight origin destination data, which is based on cellular information. And in essence, did an analysis at each of these locations along at the border and looked at where trips are going to and from and what percentage are going through the entire region. So our through trip tables were actually based on real origin and destination data. And then we produce all these numbers, which can seem overwhelming, but I'll say to you that these are typical types of plots that are done for a validation. And essentially, we're looking at error levels between different counts and our assigned traffic volumes from the model. And we compare them to FHWA standards. So FHWA has some general guidelines on what a model should produce. And at this particular point, we fall within those guidelines for all the different parameters. Again, we will continue to tweak this a little bit, but I don't expect the results to change too significantly. I mentioned that we, made some changes to the interface and how we run model. Cube Voyager has a whole model interface type setup, which likewise can be customized and programmed. So we developed a program to develop this interface and take advantage of some of the Cube application features. And I think Avinash, at the end of our training presentation, he's going to be opening up this new interface and showing you generally how it works. It may not be too intuitive, meaning there's not a simple go button. In some respects there is, but it does require a little work to understand some of the input and output files and how you select those files and some of the parameters that you need to enter. Okay, next steps and how can MPOs help? So what do we have left to do? I mentioned before that we're still making some network updates. We want to code some of the completed projects that have been done. Cleaning and updating some of the roadway data. I mentioned Adams County providing some of the center turn lanes. We'd also grab some information from PennDOT to see if we can evaluate some of the turning lanes and information on capacities. Signal locations, I think we're pretty much done. We relied on PennDOT's TSAMS program to bring in a lot of the signal information that we have throughout the entire region. Socioeconomic data updates, I think we're pretty much set on the base year. What needs to be put together is more the projections and forecasts for socioeconomic data. And again, that may fall under future activities too, is to constantly evaluate those projections. Certainly for Harrisburg, York, and Lancaster, they have already, the MPOs have done projections, and those have been formalized into the model. For Adams, Franklin, and Lebanon, we've reached out to each of you for some insights on how do we grow those households and employment within your region. And like I noted before, they're by TAZ for each of those traffic analysis zones. We need to grow the households and employment. In some cases, you provided some insights on where growth may occur, but we don't have the exact growth values. So what we were thinking is based on Woods and Pool data, we have Woods and Pool county level forecasts, that we would try to allocate those forecasts downward using some of the insights that you provided in your emails. We may make a few adjustments to the interface, though I think we're pretty much set on what the interface is. There could be adjustments done down the road to make it, certain aspects easier based on anyone's, input. I have mentioned some model validation tweaks, maybe just more on the transit side here. Finalizing some of the transit items, and then finalizing the user's guide and validation report documentation, which we'll go to with the model. We have a whole package. We're just working on the above. Ultimately, when we're done here, we do need someplace to house the model. So we're going to have to think about where do we place all the files and deliverables that we have when we're done. I say it's about 0.5 gigabyte per analysis year, but there are some options here of producing some model runs where if you want to do like some corridor summaries, you need a special file, and that can take 30 gigabyte just with one analysis year. So wherever we store this, it's going to take you're going to have a decent hard drive space to store the model. And I think this is going to get to some of our next points here we're going to be talking with shortly here is how do we think about maintaining and using the model among all of the MPO partners here at the table. Supporting efforts from the MPOs. I think I talked about some of these already. We got some information on school and universities. We got some information on our network, and then we got some information on the socioeconomics. And I think we'll continue to, I think we thank everyone here for that information, and we'll continue to probably interact in the future as those get updated and refined further. So that leads into, model maintenance and roles. I guess there's a couple issues here of, running the model and extracting that information. I think our intent today is to kind of give you a feeling of, what this model is. Certainly the second half of this presentation, what does it look like? What's needed? I know in the past we've had some of the MPOs on today who have played an active role in running the travel demand model, and that when I say active role, that mean had a valid license for the software, Cube Voyager. But I think many of you may not even have your licenses anymore. That may be a topic of discussion. And a license can be expensive. It can be $8,000 to $10,000 plus an annual maintenance fee. That's required. That may run $1,000 a year or so. There are, and this may be of interest to some. There may be an optional license to just view data. And I know City Labs, we had some initial discussions, but some maybe more may be needed if this is an area of interest, is that MPOs may be able to get a license, and maybe they're not the ones running the model, but they'd like to view files or see it and work with some of the files. And it could be a much cheaper option there to view some of that data. As an alternative to the model, we can save information out as GIS shapefiles. So there may be an option too to also save as shapefiles, and then within your GIS departments be able to view and look at the information. So at this particular point, I'm going to open up a spreadsheet that I had sent around, and certainly some with PennDOT's Program Center. I know Steve Deck. We've been talking a little bit already about some of the items in this spreadsheet, but I wanted to share it with everyone to let you know what was in it. So I'm going to have to, excuse me, I have to stop sharing, and then I'm going to share my Excel file. Okay. Can someone confirm if they see my screen? And it is an Excel file.
Yes.
Good. So what, as we talked with Jackie and we talked with Steve Deck, and I've talked about where do we put this model, and we started, lots of questions started to come out. Well, who's gonna run the model? Who's going to maintain the model? How do we keep track of who's updating what? Because now we have a model that if Harrisburg wants to run, ideally they want to make sure that the latest socioeconomic forecasts are input from all the counties when they make their runs, because those forecasts, even though they're outside their region, they can affect the interactions between those counties and their county and affect the traffic volumes. So there becomes lots of question marks here on how to move forward, and maybe this is one of the reasons why the model was not initially combined. It was everyone had their own little piece, and you maintain your piece, and that's all you run is your piece. Now things are a little different in that there needs to be some interaction, and so what we try to do here is there's really two sheets to this Excel. There's a model maintenance, and these are potential activities and anticipated roles in maintaining the model. So what I have open there is, I have the first maintenance activity is something related to the model version control and archive. Obviously, as model gets updated, you want to make sure that if Harrisburg found something and they updated the model, or it was updated for a quarter study, that when Lancaster runs it, that it has whatever fixes or changes were made that were pertinent to the overall model. So there needs to be some type of version control, plate archival, someone maybe to oversee the overall model, and certainly there's some level of effort required. It may not be a huge level of effort, but there will be some level of effort to kind of keep track of some of that information. There may be model validation. I'm going down to the second major row there. And I don't think that's going to happen very often. We've just went through a validation. I know the Federal Highway Administration would look to hope that models validated at least every 10 years, but in reality, with our changing conditions of travel behavior and everything, maybe every 5 years. I know some have strived for, but somewhere between 5 and 10 years. And certainly often coinciding with the census data release, the 10-year census is an opportune time to validate. Base year network maintenance, and this is a big one. There's constantly projects being completed. We have what's called a 2018 network right now, which is our base year. But obviously each year something gets completed. There's a new signal, a roadway gets widened. So in reality, it'd be nice to make sure that that base year network is maintained in some way. And I'd say, many MPOs across the entire country struggle with trying to update and maintain their model. PennDOT is, the same, same issue, that they've had trouble maintaining their model. They haven't maintained their statewide model that they developed. So what happens is 5 years down the road, the networks don't contain most of the projects, and now you're not sure it even reflects the existing conditions properly. I mentioned before, moving down here, we've set up a whole network for the Adams and, for any of the counties in the region. There may be times where you're using the model at a finer level or thinking of using it at a finer level, and you'd like to revise the traffic zones, make them more detailed. And obviously when you make updates to traffic zones, then you got to be prepared to not only prepare the socioeconomics, but forecast for those. So that's a level of effort to maintain the model. The socioeconomic forecast, we have, Lancaster, Harrisburg, and Lancaster, Harrisburg, and York on, and they need to go through efforts to create socioeconomic forecasts, and typically, so often that may coincide with their long-range transportation plan. Or it may be a separate effort. So that can be a rather intensive effort. I know, Steve Deck and certainly Bob Beanie and others have, had staff who have really worked and spent a lot of time in creating this forecast, and in some cases working with municipalities on identifying, and verifying some of that growth. So that can be a rather intensive exercise. And then I have some other, more model structure of, reporting feature enhancements. Are there things that we can produce, make, from this model that make it easier for you to do something? We've tried to build in a few things. I know we've gotten a lot of requests here I know some of you have been involved in some of these climate change efforts, but being done by municipalities where they're doing greenhouse gas inventories and looking for transportation estimates. And we've utilized this model, and we've actually created some model reporting features to help provide that information more easily for these efforts and for down the road. So those may be examples of reporting features. And then what we have here in orange are what we think in the past, what role different agencies have played. Certainly Program Center has been active in the past, but that's not to say that the MPOs haven't really played a role too. Especially when you get down to the socioeconomic forecast, some of these MPOs have really provided a lead role in coming up with that. That hasn't been a PennDOT exercise. PennDOT maybe in the past has helped more with the structural changes to the model, in some cases running the model and application-wise, and then the MPOs have helped prepare some of the key input information to it. And then in the model application, I give you some ideas of how models are getting used. Corridor studies, and this probably brings PennDOT, the district office, more into play. The models have been used for many corridor studies. Certainly recently, the I-83 project in the Harrisburg region made use of an early form of the South Central Travel Demand Model. In some cases, for a project level analysis, there may be some changes made to that model or modifications to make it more appropriate for that particular corridor study, but the regional model served as a basis. So in that case, the model activities are really funded through that corridor study. So in essence, the district or PennDOT as a whole played a major role in funding the application of that model. For conformity analysis, the program center is really traditionally through our contract provided a lead role in leading the model runs for the air quality purposes. So the MPOs have really helped out in coding some of the projects and or at least providing a lot of the project information. For the long range plans, maybe some like Lehigh Valley use it for environmental justice evaluations. Some of those efforts have been conducted by the MPOs themselves. So they've taken the lead role in applying it. I have their climate action plans. PennDOT Program Centers really helped take the lead in some of those particular efforts. And then there's other potential uses that I have there. So at this point, I've talked for 40 straight minutes. So I guess maybe I can get a little conversation started. I know this is probably taking a little longer than I thought, but this is an important topic. And I know Steve and Jackie are on, and they know it's an important topic too. So maybe I'll open it up to get anyone's thoughts moving forward.
Then this, I have to get off at 2 o'clock, so maybe I'll just open it up and I can set off and then leave, No, Dan, we have an existing contract that we call a travel model support contract. That we accomplish, a number of things that you mentioned in your presentation, for which historically was for our Lancaster model. Of course, now we've transitioned to the regional model, but we've been kind of continuing along in the same path, in terms of how we're supporting things. So key question for us going forward is going to be, how the funding gets handled for whatever option we end up, agreeing on among all the MPOs. Because it's somewhat of a for us is that we want to maintain the funding that we have. Whether we continue to use it for model support, I guess, depends on whether there's other funding available to support a larger effort, or do we have to take that from our base funding like we've always done?
Well, that's a good point, Bob. Yeah, and in your model, I think there have been some activities that we have done with the South Central model in previous years specific to your region, and whether it's an application for some particular items. So yeah, in that respect, the MPOs can lead the efforts of maintaining their portion, but ultimately still someone needs to provide a kind of a bigger picture when I talk about the model version control and archival, since we need to share that information back.
We really haven't paid any attention to those types of issues at all. So I mean, it seems to me that maybe we need a work group among the MPOs to work through these issues and decide how they're going to be handled.
Well, that's a good point. A working group, and maybe Steve Deck. I don't know if the working group was maybe you've discussed that previously, but that's certainly a good idea. A formal working group.
We obviously can't do it without Jackie and her team, that kind of thing. Being able to understand where all the support is going to come from.
Hello, Bob.
Oh,
Yeah, hi. So, I mean, I think that's a great idea. This is Jackie from PennDOT Program Center, forming a small work group, and I think that's the track that we wanted to hear, or some feedback from you folks. Formulating some ideas or strategies on the funding side of maintaining and archiving and et cetera. This is an ideal time because we just renewed the Baker contract for 6 years. So we've planted that seed with Dan Sakaris and his group. And then at the same time, you know, we're diving into the UPWP realm. So I think that, you know, with forming a subgroup to have these discussions, to use Dan's spreadsheet here to help guide those conversations would be ideal.
Yeah, and I think you bring up a good point, Jackie. We mentioned even if it's not, you know, us providing assistance, but there may be some items here where it's an MPO activity that you can play a role, especially for those, for example, we talk about the forecasting. It may not be something you've done traditionally, but maybe that's something that you need to add to your UPWP to at least address some of the needs moving forward. It doesn't have to be huge amounts of efforts, but at least some efforts to acknowledge that those activities need to occur.
Right. I mean, it's, you know, it sounds like it may be a team effort. It's going to be a team effort to, you know, lift this to the next level for sure. And looking at all our resources, you know, people, staffing, funding, you know, everything in place and just try to put it in its silo where the best fit and the need is to support this whole effort.
Yeah, Dan, this is Steve. Yeah, I think almost regardless of whether this gets run through the PennDOT contract or, you know, some Bob was mentioning a support contract with, I think having that work group now that it's, you know, so many parts to this model now, I think you almost have to have a group that gets together on a revolving basis to make sure that, you know, the data behind it and everything is being maintained like you just discussed. I got a quick question. You were talking about the model, you know, the fee to have the license. Diane was telling me it's $3,800 now a year for our maintenance. For that, how would that, if you know, with all the different MPOs involved in this, would everyone be having to pay that maintenance fee under certain scenarios, or is there a way, you mentioned possible ways to kind of reduce those license fees? Is there a way that to you makes more sense than other to be kind of as cost effective as possible in terms of holding a license to use this thing long term?
Well, I'd say there's no use if you're not going to run it. Here's the trouble: if you're not going to run it, and maybe, you know, in some way, you know, either we're supporting the running for, let's say, a conformity or for some, you know, regional planning effort, or another consultant's doing it for a corridor study, then there's no use paying for a full license if you're not using it. I mean, to me, that seems senseless. But that's where I wanted to explore. There may be things that you want to view from the model runs, or at least be able to open up files and to, when they look at a trip table or something and have staff look at it, a cheaper license, a viewing license makes more sense in my thoughts, at least, rather than just spending 38. Like you said, I forgot that it was that high of annual maintenance fee. So you're talking for someone new, an upfront model cost plus the maintenance fee. That's just not worth it. In reality, I don't think the smaller MPOs, they're not going to have the technical expertise to run it, so they're not going to buy that license, and nor they should. I don't think they should either. So I don't think we formally yet have sat down with City Labs, but I think that's the next step, is to sit down and see what the options are. Maybe there's a joint type license and we can see where that can be shared. You mean only one can run it at a time, but it's shared among everyone. That could be an option. Or we continue to support the run of those. I don't know.
I mean, Dan, this is from our perspective. I think we'd be hard pressed to, have staff that we could dedicate to even an occasional run. And you know how it is. If you're not doing that stuff all the time,
Yeah,
it's almost pointless to even try. So I think we'd be in that group that would want to continue to have some kind of support to do the runs for us. I think viewing and being able to see certain information periodically would be an advantage, but we certainly don't need a full license.
let me say this too, that to make the run is not, I mean, on our side, if it's really the model is preparing the inputs, getting the input data right. To physically make the run is not that much effort. It's more IT related, is making sure you have a computer to run it, and producing the button and running it. So I think if the MPOs, I think there's a role that we could play, or even through the program center, in running the model. And that's not a huge commitment, as long as the MPOs can really help in some of these other activities, in maintaining the model, reviewing the network, making sure the projects are there, are coded. Does the network make sense? Can you help with the socioeconomics? That's time intensive effort.
Well, and you know full well we've had trouble even keeping up with those aspects of it. So your point's taken. I think it would be helpful, and maybe this is something the work group can work on, is to have some structure to how that should occur. So there's a standardized way of providing the inputs, and we can become more well practiced at what's involved in having to do that part of it, because right now we're not doing a very effective job.
Yeah, I don't know if Matt Long's section could be part of this work group or not. I see Anthony's on the phone. I don't want to speak for Matt, but I think there's an opportunity that they could assist with this effort somewhere, or at least provide some input.
Okay, well, that's certainly worth exploring. I think we can explore the licensing a little bit more. We can explore the role of the Matt Long's group. And
I think that's.
Yeah, I can talk to Matt about it.
What's that, Anthony?
I said I can talk to Matt about it.
Okay.
I was just saying, having that outreach to see what license structure options there might be with them would I agree, would be a good kind of a next step that helps us understand what the options are a little better.
Okay, makes sense. Is there a data home? And when I say a data home, it doesn't necessarily mean now that you have to have the software and be able to run it, but a data home to store the model file, at least the latest version of it. We can store it certainly, but I'm sure that a deliverable we usually provide, and there's someone can hold it themselves. So ideally, it would be nice to have a home for it. And I don't know among the MPOs, and then we can explore whether the program center has some disk space to share, of whether, and maybe it's a non-issue, there's so much disk space that they could house it on their SharePoint site, and that would work, and we could have the spot there. If there is an issue, then we may see if there's an MPO. I don't know if there's any other means that you've shared information within the district region.
And I'll say maybe we might have an option for that. I'm not 100% sure, but I'll just say, we could be part of that discussion.
Okay.
Dan, this is Lori from Lancaster. What size storage are you talking about? You may have mentioned it before.
it can grow. I mean, you're talking. I'm saying at least 100 gigabytes you'd want just with the additional analysis years. It would grow over time. Right now in its current form, it's not much. We could probably house it with under 5 or 10 gigabytes of. But if we were to create forecast years and then to maybe there's the goal to create some interim years and store that information for everyone to use, then it's starts to add up. So,
Okay, I mean,
but
we
now,
have to talk to-
nowadays, I don't think we're talking anything. I think most systems, a while back, that would sound like a lot. Now, I'm sure most systems and most hard drives would have, plenty of space.
Yeah, I know we'd have to talk to our IT about that. My other question would be, and this is probably just not knowing enough, if it's stored, say, on SharePoint, do one of the MPOs need to have a backup, or should you keep a backup if, something fails and the file's lost or something, the program's lost? Or is that not?
Yeah, though I would think that if it's on PennDOT's, most of the IT systems now are being backed up wherever they're at. So I would think that wherever it's housed, there should be a backup automatically produced. But we certainly could have, periodically, it's also saved somewhere else. We'll always have it too. So, and by us having it, and it will also be backed up on our systems, our backup system. So there should be pretty safe.
Okay.
But it's also a place too, because ultimately all of us will get consultant requests. There's going to be there's studies done. There's going to be a request for the model file. So you're going to want a package where certainly you can come to me and we'll help facilitate that. But if we're not here, then you know where to go and where to have them downloaded or where to create an FTP link to provide to someone else. Okay. Well, we took up an hour, but this is an important issue, and I think we all knew that, or at least I think us and PennDOT knew that we wouldn't have the answers today, but we wanted to make sure that we talk internally on some of these issues a little bit, but we wanted to expand it to the larger group and just get everyone thinking about. And I think the idea of the formal work group really makes sense. I think just making you aware so you can understand by looking at the spreadsheet some of the activities that are needed for modeling and to consider that in your UPWP development. For us to explore the licensing a little bit more and to explore options for housing this, and whether it's with Matt Long or on PennDOT's Program Center site or on one of the MPS sites. I think that's at least some next steps moving forward. Okay. Any final points before we move on?
Hey, Dan, this is Jackie. I just sent a chat. I got to jump off the call too now, so we'll catch up for next steps if that works for you and everybody else.
That works for me.
Okay, just thank everybody and excited about this effort. So have a great day, everybody.
Okay, thank you.
Thank you. Bye-bye.
Okay. Yeah, and I don't know if everyone wants to, whoever doesn't want to keep going here with the training session, but we're going to try to, in the next hour, go a little more detail on the travel demand modeling. Okay. Looks like we still have 21 people, so we got some interested people in modeling. That's good. Gotten for fun. Oh, I just lost one on that statement. Okay. Okay, so this model training session, I may have to streamline this a little bit because I probably could talk for 3 hours on some of these topics. But I do want to provide just an overview of some of the basics of travel demand modeling. And like we said, I need to reserve a demonstration on how to run model and viewing outputs because I think I just want to make sure that you see some of this. So in 30 minutes, I have to be cut off, and we're going to move on to Avinash to let you see the model. Right up front, I want to just give you a quick idea so you know when we talk about travel models, who in Pennsylvania has a travel demand model. What you have in green there are the ones that are currently have a model. We have the SBC model in Pittsburgh. We have some informal models in Erie and Blair County that are being used. Center County has a model. And certainly we have our new South Central model that covers our counties. You have the Reading MPO, which I mentioned earlier, developed the model way back, Lehigh Valley model, and then the Philadelphia region model. At this particular time, I'd say I believe all of the models, other than the Philadelphia one, utilize that Cubed Voyager software platform. The Philadelphia model now uses a software platform called Vism. And then I'll add in that we also have the PennDOT statewide travel demand model. Let's give you an idea where travel demand models are. So when I talk about travel demand model, one important point is, and this is probably, just to keep in perspective what the goals of modeling are, it is a planning level tool. So it's not geared to some of the operational levels like the highway capacity manual and highway capacity software and some of the traffic simulation, which are really trying to get to intersection operations. I talked about we have intersections coded in our travel demand model, but we don't have the exact signal timing, all the exact information on turning movements. So there's a lot of detailed information that goes into operational analyses, and it's just not at the level for a travel demand model. So travel demand models sometimes more focused on kind of looking regionally and trying to estimate your traffic demand or the traffic volumes on your roadway while trying to do some type of more, it's quantitative, but more of a sketch level congestion type analyses. The uses of travel demand model, I'm going to highlight there the air quality conformity, because certainly that's been a primary use for travel demand modeling, and something that FHWA has emphasized back in the 90s, which really led to the use of the travel demand models here in Pennsylvania. The development of some of them was for the application for transportation conformity. But that being said, travel demand models around the country and within Pennsylvania play an important role in your long-range transportation plans. Many utilize it to evaluate and tie land use to your transportation system, look into the future, and understand corridors that may grow and corridors that may have needs, and to utilize that information in your prioritization process. In some cases, people are looking at their transportation projects that they've identified in their unfunded list and using the model to help prioritize those. Scenario planning, certainly at home here, your Lancaster MPO has a good example of utilizing the South Central model to evaluate their land use forecast. They had a couple different land use scenarios that were developed, and understanding what impact that has on the transportation system and comparing that impact to all their transportation investments that they're undertaking, really highlighting the fact that land use can play just as big an impact as your transportation investments. So it just highlights the importance. It's used for congestion management plans, the process to identify some of your corridor projected volume growth, certainly for corridor studies. Lehigh Valley uses the travel model for environmental justice assessments to look at their project impacts and see what benefits are seen, what areas get the benefits of those projects. We talked a little bit about greenhouse gas inventories that are going on for these climate change analysis being done by many of the municipalities. We've utilized the model for that. And maybe the little lesser role for transit planning, toll studies, and freight planning. But certainly for the PennDOT statewide model, freight planning is an important piece to it. I mentioned, kind of highlighted this, the strength of a model. It's really the ties between some of our socioeconomic, the households and employment data, to traffic volumes, so we can understand those linkages. And I already talked about some of the weaknesses. Is really trying to understand some of the operational details, and external travel, which is what we kind of led to the development of the South Central model, kind of trying to eliminate as much external travel as we have, keep the travel within the model. So from Lancaster to Harrisburg, normally in the old models that was separate, you had two separate models, so they couldn't estimate those linkages between those two regions. Now you're in one model region, so it can handle that a little bit better because it's no longer what we call external travel. I have a couple things highlighted in blue there where the model may not be on its own, may not be able to reflect when the peak period changes, when people make fewer trips and combined trips, when people tolerate longer trips. Those are things that the model can't predict well. Now you can reflect those in a model by periodically updating it and looking at your census information, looking at your trip lengths and things like that. You can update this information, but the model has trouble predicting it. And I'm going to highlight that now because with COVID here, there's a lot of question marks on whether what has travel behavior changed, and if so, can a travel model reflect that? And the answer is not really. I think we can tell the model how these things may change, and that may be things that we can reflect in the model, but the model itself is not going to provide those insights. Okay, I'm going to introduce you. I mentioned before the four-step process. So really, what it comes down to, I have some of these major steps of trip generation, trip distribution, mode choice, trip assignment. And it comes down to understanding, how many trips are made, where are they going to and from, what mode and what path are they going to take. And this is really the philosophy of the travel demand model. Now, this fancy flow chart really lays out, a typical travel demand model process. And up front, I'm going to start right here in the upper left-hand corner. We start with our population, employment, and really our household information. It's our land use information. In some regions, you see what in this called land use models. If you're talking about the Philadelphia or Pittsburgh regions, they actually have models to help produce the land use forecasts that are input to the travel demand model. So it's some sophisticated economic modeling that is needed. In most of the other smaller urban areas, that's done by hand. So in the Harrisburg region, it's looking at maybe you're starting with county level forecasts like we do from Woods and Pool or from other sources, and trying to allocate that growth within your county. So you're talking to the municipalities, you're seeing what they think growth is, you're trying to bring those information together, you're looking at plan developments, where are my plan developments, putting those in GIS, overlaying them with our traffic analysis zones and trying to figure out which zones grow and by how much. So that can be a difficult process on its own. And that's where the MPOs really play a role. And I know Lancaster too, have staff that really dedicate themselves to coming up with these forecasts. That leads into the trip distribution, which is, I said, how many trips, where did the trips go to and from, the distribution, and what mode they choose. And there's a lot of formulas and parameters that are needed to determine those. And often you see in orange these travel surveys that can be done. And a travel survey can be rather expensive. I know, Reading has undertaken some big ones. Philadelphia region has gone through it. Lancaster went through a household survey a while back. But there's also a lot of national resources too that kind of guide you on how many trips are produced for different types of households. And so we can rely on some of that information and the changes to that information, even if we don't do a household survey. Another important aspect is in the lower left-hand corner, we have our highway network, and that's our network, our transit network and our highway network. We need that because trips are going to be put onto those networks. And we have to do something called skim trees up front to decide where trips go to and from. We need to know travel times. So we take a look at these transportation networks, but unfortunately, we don't have travel times at the beginning of this process. So we try to estimate the travel times at the beginning and create these skim trees. We run through the model process, we produce the highway assignments, then we know the speeds because we know how much traffic volume and we can calculate the speeds. But the speeds may not be the same that we assumed in the beginning. So there's something called a feedback loop. So when we run a model, it's really a loop. It loops until these speeds converge, until the speeds coming into the process equal the speeds coming out of the process. So this is kind of a general overall flow chart. I talked too about validation early on. There's really a couple terms that are thrown out there in the modeling world. There's calibration and validation. Sometimes we combine these two terms together. Validation is making sure that your model does a good job of matching existing conditions. So you're looking at, does the trips make sense, the amount of trips, does traffic volumes make sense? Do I have trips going to, between counties and the proper, distribution as compared to real data? And then calibrating is adjusting your model to better reflect that data that you have. So you validate and then you calibrate, essentially adjust the models. So when I talk about networks, I had mentioned that there's really two types of things that we have. We have zones, which I said are often equate the areas, which are the census tracts, block groups, and blocks. And each zone has the socioeconomic data. And we have networks. And networks are our roadways and our transit routes. So they contain, the information onto our transportation system. We'll start with the zones, and I think this is Lebanon, and this is the actual South Central area. And you can see how we have broken the areas out into specific zones. So we're going to generate socioeconomic data for each of these zones, and in essence, the model is going to generate trips for each of these areas, the total number of trips that come into and out of this area based on the households and the employment in that area. The network is made up of a series of nodes, which are points, which are almost the intersections of those intersections where two roadways meet, and the links, which are the actual roadway that connects the two nodes. So you're going to see these terms of link and node related to a transportation network. There's another piece of the transportation network which is really important because it's the tie to the traffic analysis zone. It's called a centroid. And a centroid is a point that represents the zone. And so when we say for a zone that we're going to generate trips from the socioeconomic estimate, we have a calculation that says this many trips are going to come because we have this many households and this much employment. Now those trips are going to come out of that zone from a centroid, a single point in our transportation network that represents that zone. So in this case, here's a sample highway network. This isn't real, obviously. We have a roadway, surrounding this zone, and we have some local streets, and this yellow is the entire zone. So if we now were to create a model from that, we're creating a centroid, which is one point within that zone. And we create these little connectors. These are imaginary links. Now when we create these imaginary links, think of them as if they're part of our local system. So you see how our local roadways connect to First Avenue, Dole Street, and Second Avenue. We have two local roadways. So when we have this one big zone in our model, we have the central point where the trips come out of. Now we have these imaginary links, but you know what? We connect similar to the local street system. So when the model generates traffic out of these imaginary centroid points, which represent the zone, it comes onto the network at a point that's reasonably consistent with the access points that actually are out there. And what we end up with then is in our highway network, this is the highway network and the zone on top of it. And the black triangles are these centroids and the connectors of the trips that come out of each of these zones. So you can see the black triangle connecting. And you can connect out to as many points as you want. And typically the way we do this is we overlay this with an aerial photograph. We look at the local roadway system and we make some type of assumptions of where it's best to connect those links to. What you can see too is that the smaller the zones, probably the more accurate representation you can get of the loading points. And this just gives you an overall feeling within our South Central. We have over 2,411 zones and how they're distributed within the counties, and to see all the centroid locations that are in there. So again, when we have our overall highway network, there are a lot of imaginary links, which aren't real roadways, but just represent the connections between the traffic zone system and the network. Now, for each of these highway links within our model, there is essentially a database that has information for those links. And you can see that information has information on the roadway lanes, the functional class, the speed limits, the capacities. They have information on the signals. Everything's in there. And we use this information for our project coding. So here's a network attribute table that contains some of the variables that we have in there and how they're coded right now. And you can see for number of lanes, we have a variable for those links, and we can use it to represent highway widening projects. So if we're changing a lane to 1, a lane to 2, then that could be used. We have turn lanes that could be coded at the intersections. And this is where some of this information we don't have on existing conditions real well. So we have the variables there, but we're looking for support and trying to identify where these existing turn lanes are so we can code them into the model. We have center turn lanes, and we have even some generic capacity adjustments that we can use to reflect other types of projects, maybe shoulder widenings or maybe things that could affect capacity, but they're not a formal lane increase. We have the information on the speed limits, the posted speed limits, because when we calculate congestion and speeds, it's all going to come down to what's your free flow speed as a starting point. And then we have variables here that we use for our validation. I talked about all the traffic counts. They're all coded onto the highway network. When we generate trips from each of the traffic analysis zones, we actually generate trips. I said we're going to use that household information. We're going to also use the employment information, and we're going to generate different types of trips, home-based work trips, home-based other. This is just showing you different types of trips. And the reason we generate trips for different types of purposes is they have distinct locations they may be going to, and they have distinct time periods that they may be using it. So understanding the types of trips helps us understand a lot more about where that trip's going to and how we link them up. So that it really leads into the trip distribution. And you can see for the home-based other, we break them up. We like to know the schools and the shopping and the universities because if we have those schools and shoppings, we can send them to the right locations. So this kind of gives you a highlight of some of the trip purposes that we have within the South Central region. Another thing you'll notice is that our trip purposes are broken up by income level. We have low income and work, home-based work trips, and we do the same things for shopping and home-based other trips. And you ask, why do we do it by low income and high income? Well, in Pennsylvania, our transit ridership is so tied to the income level that it's important that we know that when we generate the trips, so we can make more insightful decisions on some of the mode choice options that are available to each of those groups. And when we calculate trip generation, we actually look at trips even differently. We're calculating trip productions. Trips are produced from your home, and they're attracted to, for example, employment sites. So we have different types of equations. We have equations that generate how many trips are being generated from a household, which is going to be dependent on your household size, your vehicles available in the household, those types of information. And we're going to have estimates of trip attractions, which are going to be some of our retail, how much, how much employment do I have in a particular area? Those are going to be attractors to trips. So in a way, we break out our trip generations by these productions and attractions. And there's different types of formulas and models, from regression equations to these cross-classification tables, and even the ability to have what we call special generators. Looking at, our equations may not be perfect in reflecting special type of situations. They may be, a special type of mall, or any mall really has special generating features. So airports, special type of freight facilities, whatever it may be, you can set up special generators to really hard code some of the, trip attractions at those locations. Lots of data you can, obviously we're using our socioeconomic data for the trip generation, but we're also using, survey data on typical trip rates for different types of households. There's some national researches, the ITE trip generation handbook. All of these information go into the rates that are used within the models. In this case, this is how many trips are produced. We are looking at household size. So from the census information for each block group, we can kind of find the distributions of how many households by, one-person households, two-persons households. We have income levels. We can break those up, and then we can kind of figure out how many trips are produced daily from each of these household types for each different purpose. And this is the actual socioeconomic input file that comes into the model, which has every TAZ, the total population. These are the files that we're producing or looking for the MPO help in producing. It has all the employment. We talked about all the categories that we need, the school enrollment for every TAZ. And we use this information with those trip rates to estimate the total trips produced. Trip distribution, using some back to science class, the gravity model, to try to figure out what are the, how we distribute trips between each TAZ. We can make adjustments based on census data and based on the typical trip lengths that occur in a region. So by looking at some of your journey to work information, this can make use of streetlight data too. You can kind of see, what is the typical distribution of trips by different trip lengths? And we can utilize all that information to kind of impact our trip distribution model. And when we, from trip distribution, what do we ultimately produce is a trip table from every traffic analysis zone to every other traffic analysis zone. These are the number of trips that would occur, in this case, for the daily total. So this is ultimately what the model produces, is a giant trip table between every TAZ. I said at external traffic, though, is a little bit different because we need to tell them something. So for external traffic, we need to prepare traffic counts. So these are all the locations at the border of your model. The model doesn't have a zone. It's not an internal zone that you can assemble a employment or households for. It's a roadway location that comes into your region. So in that case, we use count data, and we have information from Streetlight that tells us, where generally is that how much of that volume is going through our region, how much is staying within our region. And there's ways to adjust those trip tables, those external trip tables, to different years using a process called FreightTar. I only have 5 minutes, so I'm moving quickly here. Mode choice, we have the opportunity to split those trips into different modes of travel. And how do we do that? Well, we're looking at the travel time it takes over, and what we can do is the model can look at driving, how long it's going to take, but then it can also look, well, let me take, let's say I want to take transit. How far away is this zone from a transit stop? What's the cost of driving versus cost of transit fares, the cost of parking, tolls? How many transfers would it take for me to get there? All this data is processed between every origin and destination zone to make decisions on which type of travel is taken. So there's lots of equations that are developed, something called utility equations, and certainly the data and transit surveys really lead into this. And we have coded all the transit line information. Essentially, every transit line is coded in here following the highway network. These are all the nodes, and we link up and put these transit routes in, and we specify which of these nodes are stops, transit stops. And finally, we need to assign this to the highway network, and that's where, certainly, travel time, trip costs, there's turn penalties, there are certain locations or turns that might not be allowed that we need to reflect into the model. And the model needs to estimate congestion, and the way it estimates congestion is something called a volume to capacity ratio. Based on the volume it looks at, it needs to calculate a capacity for every link segment. If it has a capacity, then it can calculate a VC ratio. And with a VC ratio, it can then estimate how much reduction in our free flow speed occurred. So these are kind of national type research curves developed way back, some of them back in the 1960s, and been used for transportation planning purposes for many years. And the model then produces on our highway network, that same network that we input, outputs fields onto that highway network, which have the volumes here by time period. So all those trips get assigned to our highway network, and we produce these traffic volumes. And this ultimately, viewing this network, lets you see what these traffic volumes are, and you can post them up and compare them between different alternatives. I've already talked about validation, certainly going through an effort to check and verify our project data. I showed you these counts that were used. I showed you that. And in our last 2 minutes here, this is the key model outputs that come out of a model. We have a assigned model network that has all the traffic volumes on it and the VC congestion ratios. We have the trip tables, which tell you the trips between every traffic analysis zone. So you can aggregate those and use in custom groupings. Maybe you have planning regions within your area region, and you want to look at the number of trips between each of those planning regions. Certainly, you have travel time data and you have transit ridership. So these are some of the key model outputs that you can view. And we've produced some performance reports that can summarize the traffic into each of your regions. And we can actually set this up for different corridors too, where you can look at different corridors and look at how much VMT, how much vehicle hours of delay, congested speeds, lanes, miles of level service D. These are all types of parameters, and we can work through and develop more customized reports moving forward too. Final things is, let's say a consultant asks you to provide, what model growth that you have from your regional model for a particular area. Be careful, because the model isn't always exactly what a count is. So you want to use the travel demand model for change and then apply that change to a traffic count. So this model application chart, this actually comes from NCHRP reports, national from TRB, of how to take a model, apply the difference. It's nothing earth shattering. It's looking at the difference between the model and applying that change to the traffic counts. And you can do that in different ways. You can look at the model differences absolute, as a ratio, or as an average between these two methods. So I know in the past that people have asked me, Lancaster, what's your growth rate for a particular area? I'm following approach like this to extract some of the travel demand model volumes. Okay, I'm not going to go into the conformity. I'm going to turn this over to Avinash here, who's going to open up the software and just let you see the travel model a little bit in action. So Avinash, I'm going to stop sharing.
All right,
And see.
Dan. Let me see.
At the bottom, you should see a share button.
Yeah. Right. Can you see my screen?
I see your Windows Explorer.
Yeah, with the folders, right?
Yep.
Okay. All right. Did anybody have any questions on Dan's presentation?
Yeah, sorry I ran through that quick, but I did want to reserve at least 30 minutes here for Avinash.
All right. If not, I'll move forward. Well, good afternoon. First, I want to introduce myself. My name is Avinash Sinha, and I'm the technical lead on this project and the previous South Central model. I have extensively worked in the past with all the District 8 models, Harrisburg, York, Lancaster, run conformity runs for them, validation to the base year 2010. So I'm familiar with this area. So let me just begin by showing you where the model is housed. Right now, the model is housed directly under the C drive, under the South Central Regional Model folder, SCRM. There are 4 folders under the SCRM folder. Applications folder contains all the model scripts. I'll open it up. All these steps are here that Dan was mentioning, the 4-step process, so trip gen, trip distribution, mode choice, and your assignment step. And each one has the script that are needed to run the model. The second folder is the base folder. I'm hearing a feedback. Can everybody hear me?
I hear you clean. Yeah, I don't hear any feedback.
Okay. The second folder is the base folder where all the scenario model run folders are basically when you create a scenario, it creates a folder by the name and then it stores it under the base folder. The third folder is the inputs where all your model inputs are stored. So socioeconomic data is in this DBF file. Then you have your transit line files, your highway network, current penalty file, and your external data that goes into a model run. And finally, the fourth folder is parameter. It's just the friction factor that goes into the trip distribution is stored here. And then there's an equivalency file that helps in creating model reports, the performance reports. The model interface is contained in this catalog file. It's called scrm_model.cat. To open the model interface, you just double click it. And it should open in Cube. Hopefully everybody can see this screen now.
Yep, you're good.
Okay. Alternatively, you can just go into File menu in Cube and then open the catalog from here. So there are 2 ways of opening the catalog. Cube basically uses a flowcharting environment for designing and building transportation models. The South Central model is also created in this environment and shows up in Cube like a flowchart. As you can see here, there are 4 main steps that Dan discussed earlier, and then there are some intermediate steps. The main ones are the trip generation, trip distribution, mode choice, and your highway assignment. And then you have your feedback routine, your network skimming, time of day. So these are your main steps that model needs to, entire model run takes about 12 steps to run, to complete. Then here, as you see on the left-hand side, these are the inputs that go into each step. So for network preparation step, you have your highway network and the zonal data file. So those two are required files for this step. And on the right-hand side are the outputs that come out of these steps. When you open this catalog, Cube displays these 4 side windows. These are part of the scenario manager windows. The first one is your scenario window. This is where you define your scenarios. Right now, I have the base year validation run here. You can create new scenarios here by, I'll show that later on how to add a new scenario. The second window is your data, where all the inputs and output data that's here on this screen are listed, and you can double click and open them. These files. Outputs has the assigned network, you can double click and open. The third window is your applications window. Cube calls these steps as applications. So when you click on them, it will open the all the steps that are part of a network preparation step. So inside each of them, there's multiple steps that need to be run to complete the entire model run. So network prep has area type calculation, finding closest node to external station, calculating speed and capacity. So these are all run under the network step. So these are all your 11 or 12 steps that are right here on this screen. And then you have the fourth window, which is, I guess, where a model user will likely interact with it, change these values for making a model run. These are called keys. I'll show you how you have to change these and how you update these when you run a scenario. So for running a scenario, all you need to do is basically you can either right click on the scenario and say, edit/run scenario, or you can go to the scenario tab here and then click this green run button. So I'm going to just click this run button, and this will show you basically the interface and where you have to input all the information needed for a scenario run. So this is a base year scenario run. Here I have provided an option, to select the type of scenarios you're trying to run, a future year conformity run, or future year scenario. You can actually edit this if you wanted to, run something other than these 4 categories. It provides an option to edit it, directly type the scenario you want to run. So I'm just gonna, show you, like, you can type test scenario. The other things that you have to modify here, like this is a base year scenario, so it needs a 4-year digit for the year. So if it's a 2045 run, you will select, you will type in 2045. For now, I'll change it back. Then you have the 2-year digits, 2-digit year. Here you will just provide the last 2 digits from the year. So if it was 45, I'll type 45. Then Dan was talking about zones. So there are 3,000 zones. Right now there is a space for 3,000 zones in the model. So the highest internal zone number right now is 3,000. And then, last internal zone number is 3,000. And the highest zone number, including the external stations, is 3,200. These are default. For a scenario run, you won't be changing these. These will remain same. And this interface is similar to the interface that was used in the previous county models, the central software that was used. Basically, that also provided option of selecting your inputs, your network files. Here also you can just browse, and then it opens up the window where you can go to the folder where your inputs are stored, and you can select your files. So you go through this exercise of selecting all these network files or socioeconomic files. There's a next screen where you have to provide the external files. Then there are two model run options where one, the bottom one is deleting temporary files. That is checked by default. So basically model, when it runs, it creates some temporary files that will increase the size of your total run. So you don't want to basically, if you don't want to increase the size of the run, you can just keep it checked and it will delete those files. Then there is an option of saving an assignment path file, which basically stores all the movement from each zone through each iteration of the model. It's a large file. It's kind of a 7 GB each for each time period. So it's actually a 30 gigabyte file. And it lets you perform select link analysis if you want to. We have done that in the past with the greenhouse gas inventory. We have run that path file and created some of the outputs for you. But to save space, you would have this unchecked. Once you have done all that, you will just hit run. It will start running the model. I don't want to run it right now because I want to show you something else. So let me go back and close this up. It will ask you to, because I was making changes, it's asking me to save the scenario. So let me decline that for now. What I want to show you is how to create a new scenario. So what you do to create a new scenario is basically you right click, and there are two options here: add child or add sibling. Adding a child basically creates a scenario under the 2018 folder. So let me add it. So it's kind of it takes the characteristic of the parent. So basically it's taking the characteristics of the base year model. So if I create a child scenario, it's going to create like a substructure, and let's call it test whatever 2018. So when I create that scenario, I press enter. It opens up a dialog box where you just type a description, test scenario run. The code is not important. It's just a way of catalog to track which model run it's making. So you just do that and you create a scenario. So once you create the scenario, you see it takes all the information that was already provided under the 2018 scenario. So it's kind of taking that and already filling that. So to select new files, you will just go through browse and select the file that is needed for a test scenario. Let me close this.
So most cases under a new scenario, you're either changing the network, meaning you're adding this. It could be changing a project. You could be doing something with the network and you want to test it, or you could be changing the land use inputs, which is maybe a new scenario land use file. So there's probably two files of all those inputs that really the ones that are, major ones that you'd be changing.
Yeah. So you can call it, test land use scenario or test network scenario. And so the other way of adding a scenario is adding a sibling, which is like creating like a brother, right? So of a scenario. So let me call this a 2045 model run. And I again press enter, and this opens up this window again. And you say, 2045 model run. Say okay. And this, for now, it's taking the information from the base scenario, which is like a default parameter or keys that are provided. I can delete all these and it will create, you know, a empty interface where these will all be blank, you know, like this. And then you will go browse, you know, select the 2045. So I have a 2045 inputs. I'll just select the 2045 network. And it shows up here, right, under the 2045. So you will keep on going, defining all these, selecting the all the files that are required for a model run by basically browsing and going to the right, you know, named folder. Basically, transit is under transit folder, so you go to transit, and you keep selecting these. The other way to quickly change would be, you know, just updating these, you know, by typing it in. You know, you can, instead of browsing and selecting, this can be just typed in. And once you have defined all those files, you hit save, then it updates the keys here. And what I want to do next is to show you that when you go under base, it automatically adds a folder for that scenario, which is right now empty. So when you run the model, it's going to start producing all the outputs right under this folder. And I think I created a child scenario. So let me show you that it does create. When you create a child scenario, it will create under, you know, the folder where you created the child scenario. So under Y 2018, I had created a child scenario. So I called it test 2018. So it creates a child scenario under, you know, Y 2018, year 2018 folder. So as long as you keep adding childs, it will keep adding a, you know, sub folder. So if I create a, you know, another child under 2045 and test LU land use 2045 and I hit enter, it will open up the scenario setting menu. But I go back to the 2045 folder, it will have created a, you know, subfolder named the same name that you provided on the scenario, under the scenario window. So to run, you just, after you have defined all your scenarios, you just hit run, and it will start running the model. I don't know if I'll hit run here to show you what it does.
With our time too, Avinash, maybe we'll go straight to the network, open up a network.
So yeah, I hit the run and then it's just to show you it's running the model here. And it opens a task monitor and then it shows you all the steps it's going through. It provides the descriptions. You can stop the task by, you know, pressing this red button. So I just abandoned the run. So I abandoned. All right, so the other thing I want to show is the network, right? So to quickly open files for a defined scenario, all you have to do is, let's say I want to open the highway network. I'll just click the edit button that's on this right hand side. So you just click this edit button. It should open your network, the model network that you have seen in the in Dan's presentation. So let me go through some of the basic of what you can do and how to create a project, how to modify certain attributes for a project. Can you see the network, Dan?
Yes.
Okay. So up top, you see there are some of the basic, you know, zooming in, zoom out, those kind of buttons here. So like this is the pan button, you can pan around. This is the zoom button, you can draw a rectangle with that and it will zoom in. This is the zoom out. Just like a ArcView, if you are familiar with ArcGIS, you will know these. Then we have a zoom all button here, which basically brings it back to the original. What else? This pointer is the select button. So if you wanted to view attributes for a particular link, you will basically, let me show you, zoom in here, and I want to see the attributes of this particular link. I'll just select the pointer button and click on the link. And this shows you, like Dan showed in the presentation, all the attributes that are for that lane. So it is, one lane in each direction. Name is here, doubling gap, the FIPS code, the county code, county name, your route number, RMS route number segment. You have your fact type, which is facility type. Area type is calculated by the model. So when we provide the user's guide, we'll make sure which ones are basically used for to add a project or modify something. Speed limit is here, your lane capacity, which is calculated by model. Some of these, which is basically defining intersection, center turn lane, all these attributes are here. What else? So to add, all right, to update, let's say I wanted to add a lane for this particular road, right? I wanted it to be a 2-lane road, both ways, both directions. So all I need to do is basically go to the attribute that says lanes and select, and then just type, it's going to be a 2-lane, right? So I just type 2 lanes, both direction. You can have a road where one side is 2-lane and one side is 1 lane. So depends what your project calls for. So I'll just update 2-lane, and then I'll say, save that current item, then it will save that information. So this became, only this part of the road became a 2-lane road. So if it's an entire stretch, you want to make 2-lane, you'll have to go through all the lanes. There are easier way to do it by drawing I don't know how much to go into detail, but you can draw a polygon around certain links, and then update all of them that are inside the polygon. Like all these are selected, right? So you have to be careful. You're only updating the roads that you want to update, not all the roads. So all the roads that are crossing the polygon. So you can do it like by drawing a polygon around it, and then going to link, compute. It's probably going in too much detail, but in equation, and then you say lanes equal to, and you don't want to say apply all items. All items now will make all the links in the model network 2 lanes each direction. You want all items that are inside the polygon, and then you say apply, and then it applies that to 38 links that are inside the polygon. So all of those became a 2-lane road. So if I go here now and click on it, it's a 2-lane road all the way through. So there are easier way to do it. You have to go through it multiple times to basically find a way to do it faster. But this is a way, instead of clicking all the links and updating it, you can do it like this. This is like selecting a road in ArcGIS and updating its attribute. The other thing I wanted to show was how to label or post information about a highway link. So to do that, all you need to do is, there's a post all button here. You select that. I'm just going to make it blank. So let's say I wanted to post information about lanes. So I select the lanes attribute. And then there's a link color and a fixed color option. Fixed color basically lets you choose the set color. So you can have all the links with green posting. So I say fixed color with green, right? So when I say lanes, and then it will show all the, it will label all the links that you just updated with two lanes, right? And this one I didn't update because it's not inside the polygon. It remains one lane, but the others are there. The other things you can, for editing, you can post multiple things. So if you wanted to post a road name also, and just leave it as link color, then it's gonna post wherever it has a road name. So I zoomed in and it posts the road name. What else? How to add a new project. So that was just adding a lane, basically just widening project. But if you wanted to add a new road, so I'm gonna zoom here just a little bit. I don't know which.
We probably got 2 minutes, so you could just visually show. Maybe while you show you add a lane, I'll also tie things up verbally here.
Yeah.
I know there's a lot here, and we crammed into 2 hours, or really 1 hour in the training. But I think the idea here was just to give you a little idea about travel modeling, let you just see the software in action. And I think you got a little viewpoint of some of the file management that can occur, how you run it, some of the menus, the network editing. I mean, this is what we're doing to code projects, like for a transportation conformity. Avinash just added a new link. So yeah, to give you a feeling of what it is. Obviously, you're not going to learn it just from this visual in this short of time. But so I guess in the end, I think certainly we could do more in-depth training down the road. But I think at this particular time, we thought that this 2-hour session would be appropriate. I guess any final comments or insights of moving forward, let me know. I'll open it up here as we end the meeting. Was this useful? Do you want to see more? Did it not give you enough? Did it give you too much? Was there something that you were wondering about modeling that we didn't answer here on this call that we can maybe work forward to making sure we address that issue?
Hey, Dan, it's Lori from Lancaster. I
Yeah.
just wanted to say, yeah, thank you. This was informative. I mean, I always learn more every time you guys give a presentation. I think this is, more understanding for us. I know there are a couple people, Christiana and Gary were also on the call. Bob had to jump out, but giving us some more information who haven't been really involved in the thick of it or anything. So thank you.
Okay. Yeah, and this whole software is very similar to if you're used to GIS. I mean, it's almost like you're in a GIS world. The whole network editing features of it.
Hey, Dan, this is Steve, and I gotta jump off and do something else as well. But I agree with Lori. I think this was good enough to get, to have a good follow-up work group discussion like we were talking in the first hour. That I think this gave us enough of an understanding that I think if we got back together, we could answer many of those questions, or at least have a pretty good preliminary answer on many of those things in your spreadsheet.
Yeah. And you know what? A work group gets started. There may be maybe we do like, for a work group, we could have, each work group, we do a 20-minute demo, and maybe it's focused on coding a new project, and it's focused on that. And each one we could do something different to give you some ideas of what's happening and the type of information we need. moving forward. So
Yeah, Andrew was talking earlier about maybe some follow-up training on how would you do an EJ analysis, or how would you do some of those practical applications that we're likely to do, at least an intro to some of those and how we might use it moving forward.
yeah, great. That was a great idea. We have I know Tushar and Anna on here from AECOM, and they've helped with a lot with the EJ modeling. So that I think, yeah, we could do those. Yeah, those topic areas could be addressed as needed.
Dan, I would say from our perspective as somebody who hasn't done modeling at all before, time to digest all the options here and figure out how we would use it and all that, those sort of details, because it's a big ask or task for us to see how it would fit in and how we would do it. So
Yeah, yep. And again, I don't know if the intent is for every individual people right here to be running the model. We don't know that yet. I think the goal here is just to let you visualize this black box to see a little bit more of it, even if you don't understand it all, to at least to take a next step forward of what this modeling is.
Well, Andy, in response to that, I'd say maybe that could be, like Dan said, one of the meeting topics of more of the uses or the possibilities that the model can do, because I know we've started in on corridor analysis and also looking at bike ped, which there are limitations that way, but with streetlight data and all that. So we know that we've, maybe looked at 2 things out of 100 or more that the model can do. So I think that would be, Dan always has suggestions for stuff that we can do more with it to help with our planning. I mean, we did a lot more with it with our MTP this round. So, I mean, you could talk with Dan offline, or, we could do that as part of the work group training session.
Certainly.
acknowledged.
Okay. Well, it's 3:03, so we went a little bit over, but I thank you for joining. We recorded this if you want to put yourself through this again. If not, I think we'll work to identify a work group and maybe get together here on a periodic time frame, a couple times a year maybe, and then have some different topics we can present on in more detail, and hopefully advance the whole modeling understanding within the region. So I appreciate everyone joining. Thanks, Avinash, for running that through. I'm sorry I didn't give you the full allotted time. So
Yeah, that's fine. We can cover it sometime.
yep. Okay. Thanks, everyone.
Thank you. Bye-bye.
Thanks so much.
Thank you.
Bye.